let's solve this complicated looking linear equation. 8 plus the quantity 2x minus 1, all of it divided by 3, equals 11x over 4 minus 1. The first thing I want to do is I want to clear the fractions, and for that I will need to know what number to multiply through by, which I will need to find the least common multiple of 3 and 4, and that is equal to 12. So finding the least common multiple of 3 and 4 is probably more familiar, or maybe more familiar to you as finding the least common denominator of two fractions where one denominator is 3, the other is 4. Okay, so the LCM, or least common multiple, of 3 and 4 is 12. I'm going to multiply through both sides of the equation by 12. So I'm going to write 12 times the quantity 8 plus 2x minus 1 divided by 3 equals 12 times the quantity 11x over 4 minus 1. Okay, so now I'm going to have to distribute the 12 through. That's why I wrote things down step by step. So I actually wrote the left side of the equation in the parentheses separately, and same with the right side, so that when I distribute the 12 through, I will not make any mistakes, or at least I will see better if I do. I will notice easier. Okay, so now I'm multiplying the 12 and this fraction on the left side of the equation. So I'm going to write 12 as a 12 over 1. And again, now I'm on the right side of the equation, and when I distribute the 12, the first part of the difference is actually a fraction. So again, for that reason, I'm going to write 12 as a 12 over 1, minus then 12 times 1 is what we subtract off. Okay, so then we have 12 times 8, which ends up being 96, minus 12 here and the 3, well, they cancel, and that leaves a factor of 4 up here. So now I'm going to be very careful. What I end up having is a 4 times, now just the numerator of the other fraction, because all I had was written over 1, so 4 times the whole quantity 2x minus 1, and this is going to be equal to, here I will cancel again, so I cancel the 4, that leaves 1 here and a factor of 3 here. So I'm going to write this down on the other page. So 3 times 11x minus 12 times 1. Minus 12 times 1, I'm just going to write it as a 12. Okay, so now notice that even though we distributed the 12 once, because the numerator of one of the fractions had more than one term in it, I will have to do yet another distribution. So here we have the 96 minus, and now I'm going to distribute the 4 through this difference in the parentheses, and in the parentheses, and so I end up with 8x, and then I have a minus 4 times a negative 1, which gives me a positive 4. Do not forget to change the sign for both of the terms. That's a fairly typical mistake that students end up making. So here we end up with 33x, and then just the minus 12. So now we have a better looking linear equation that we can now try and solve as we normally would. So what I'm going to do is first just add up the like terms. So here we'll end up with a 100 minus still the 8x is equal to 33x minus 12. Now I'm going to add 8x to both sides, and I end up with 100 equals 33x plus 8x ends up being 41x minus 12. Now I'm going to add 12 to both sides, and I end up with 112 is equal to 41x. Okay, so let me copy that, and I'm going to write it in, I can switch the sides of the equation. So I had 112 equals 41x, and now I'm going to write down 41x equals 112. Now I'm going to have to divide through by 41, the coefficient of x. And as I divide through here, I have the desired factor of just having x by itself, and on the right side I end up with the fraction 112 over 41. And 41 doesn't seem to divide into 112, and 41 doesn't have any factors because 41 is a prime, so it doesn't have any other factors except itself and 1. So basically I'm done reducing the fraction here, and this is my final answer. Okay,